We are going to finish up our 5.4 notes today. So with this one, we're trying to find the exact value of sine of u plus v. And I've given you sine of u, and I'm giving you cosine of v. So first thing you want to do is look at your sum and difference formulas for sine of u, plus v, which is sine of u cosine of v plus cosine of u sine of v. So I have my formula, which means I need to know sine and cosine of both angles. So I'm going to go ahead and draw my triangles in their correct quadrants, based on where it says the angle lies, to make sure that I get my positives and negatives and everything else set up correctly. So between 0 and pi over 2 would be in quadrant 1. Don't forget your triangle is always drawn to the x-axis, so that's angle u. Sine is 4 over 5, which means this side is 3. Over here this says v is between pi over 2 and pi, so that's in quadrant 3. Again, drawing my triangle to the x-axis, there's my angle v. Cosine is negative 12 over 13, which means this side is 5. Alright, so sine of u is actually 4/5 times cosine of v, so I come over here, cosine is negative 12 over 13, plus cosine of u, so that would be 3/5, times sine of v, so 5/13. When I multiply these, I end up with negative 48 over 65 plus 15 over 65. I'm not reducing this second fraction, even though I could, because I'm going to be adding here. I need a common denominator. So I end up with negative 33 over 65. That's my answer. That is my value of sine of u plus v. Alright, evaluate cosine of arc tangent of 1 plus arc cosine of x. So this is cosine of u plus v, which if I know my sum and difference formulas or look in my trig book, cosine of u plus v is cosine of u times cosine of v minus sine of u times sine of v. So just like in the last one, in order to know these, I'm going to need to draw my triangles. This says nothing about where each angle is, so I'm just going to draw a triangle. This is for angle u, so this is for the first one. It says arc tangent of 1, so that means I do tangent and my answer is 1, so that would be 1 over 1, which means this side is the square root of 2. For my second triangle, I'm going to say this is angle v, and it says arc cosine of x. That's how I got angle v, so that means I did cosine and my answer was x. So x over 1 for adjacent over hypotenuse, which with Pythagorean theorem means this is the square root of 1 minus x squared. Don't need to simplify that anymore, I can't anyways, but this is where I'm going. So cosine of u is 1 over radical 2. Cosine of v is x, or x over 1, whichever way you want to write it for there. Sine of u is 1 over radical 2. And sine of v is the square root of 1 minus x squared. And again, just like this first one, you could put both of those over 1. You do not have to. When I multiply over here, I end up with x over radical 2. This is minus, and then this will be the square root of 1 minus x squared over radical 2. So when I combine these with my common denominator, which is radical 2, I end up with x minus the square root of 1 minus x squared. And again, that was all over radical 2. Yes, that's not very pretty looking, but it is still my answer. It does not have to be pretty. Sometimes you cannot simplify. You got to go with what you know. Build your triangles. It's okay if there's square roots. It's okay if there's x's. And then plug those into your formulas. Prove the cofunction identity. So I'm going to be manipulating this side in hopes of trying to get to the sine x. And I chose to manipulate the left side because it's the more complicated one. So when I do that, this is cosine of u minus v, which if you look at your sum and difference formulas, is going to be cosine of your u, or cosine of your first angle, times cosine of your second angle, plus sine of your first angle, times sine of your second angle. And this should equal sine x, so I bring that down with me. Cosine of pi over 2, so if you need to think about your unit circle, that'd be up here. So cosine is 0, so I have 0 times cosine of x, plus sine of pi over 2 would be 1 times sine of x. 0 times cosine of x is just 0. 1 times sine of x is sine of x. So I have sine x equals sine x. That was a cofunction identity that we did last week. It should be in your trig identity book as well. But this is just showing you where that comes from. So simplifying. So for this first one, this is like cosine of u minus v, so that's going to be cosine of your first angle times cosine of your second angle plus sine of your first angle times sine of your second angle. Cosine of 3 pi over 2, so if you need to think about your unit circle, that'd be down here. So that's 0 plus sine theta, and then sine of 3 pi over 2 would be negative 1, so cosine times 0 is 0. I have negative 1 times sine theta, which is negative sine theta. On the second one, tangent of theta plus 3 pi, this is the first tangent one we've done, so I will go ahead and write that formula back out for you. Oops, tangent of u, sorry about that, plus v equals tangent of u plus tangent of v all over 1 minus tangent of u, tangent of v. So when I do this, this is going to be tangent of theta plus tangent of 3 pi all over 1 minus tangent theta, tangent 3 pi. Okay, so tangent theta I can't change. Tangent of 3 pi, if you need to think about your unit circle, this would be 0, 1 pi, 2 pi, 3 pi would be over here. Tangent is y over x, so in this case 0 over negative 1, which is 0. So I can plug that in for my tangent of 3 pi. Ignore that piece there. So tangent of theta plus 0 is tangent of theta. Tangent of theta times 0, which is be 0. So I have tangent of theta over 1, which is just tangent theta. And if you think about that, that does kind of make sense because you're over here, and instead of taking off 2 pi to get back to just tangent, wherever your angle was, like you would with normal, with your unit circle, 2 pi is a full circle. For tangent, pi is your full period. So taking off 3 pi, 4 pi, 5 pi, 6 pi, any number of pi, or adding that much, would just bring me back to the original angle. Alright, so 7, we are verifying this. I'm going to work on the left side, but just in the sake of space, because I think I'm going to write too big, I'm not going to keep copying this right side down. Know that you should. I just do not have the space. I'm going to write way too big for this slide. So over here, this is all going to be over x. Sine of x plus h is going to be sine x cosine h plus cosine x sine h minus sine x. So I'm going to try to put my sine x's here together. And actually, just with those two, I'm going to factor that sine x out. So just so I don't mess it up, I'm going to go ahead and bring down my cosine x sine h. And I do know that I want to factor out the sine x's because over here there's a sine x that's factored out. And actually this is minus, I'm just going to go ahead and make it minus sine x that I factor out. So I took negative sine x out of here, I'm left with 1. Negative sine x out of here, I'm left with a negative cosine h. From there, if I split this numerator, I'm going to have cosine x sine h over h minus sine x times 1 minus cosine x, cosine h, my fault, over h, which would be the same thing if I want to just bring the cosine x out front so that I can kind of keep my h's together, sine h over h. And the same with the second one, bring out the sine x so that we can keep the h's together. So 1 minus cosine h over h, which is what I had up here. Sorry about that. So it looks a little ugly, but if I just keep following my sum and difference formulas, looking to maybe factor things out and rewrite. Alright, find all solutions. So that's not just between 0 and 2 pi, that is all of the solutions. This is sine of two things added plus sine of two things subtracted. So this first part I'll rewrite as sine x cosine of pi over 4 plus cosine x sine pi over 4, and then plus, over here is going to be sine x cosine pi over 4 minus cosine x sine pi over 4. My cosine x sine pi over 4 minus cosine x sine pi over 4 will cancel, so I just have two of these, the sine x cosine pi over 4s. So 2 sine x cosine pi over 4 equals negative 1. So sine x, 2 sine x, cosine pi over 4 is radical 2 over 2 equals negative 1. 2 times that is just going to cancel. So now I have radical 2 times sine x equals negative 1. So sine x equals negative 1 over radical 2, which would be the same as negative radical 2 over 2. So if I'm looking just from 0 to 2 pi, sine is equal to negative radical 2 over 2 at 5 pi over 4 and 7 pi over 4. So these are my answers from 0 to 2 pi. If I want all of my solutions, then I'll have 5 pi over 4 plus 2 in pi and 7 pi over 4 plus 2 in pi. Big thing to remember with these is don't get overwhelmed when you have a lot of sine and cosines going on. Do rewrite them using your sum and difference formulas. And when given the opportunity to actually evaluate the sine or cosine, so for instance here, cosine of pi over 4, that is a real angle, pi over 4, do that. Whereas x is not an angle that I can evaluate yet, so I'm just going to leave that one there.